Okay, so today we are going to talk about Pythagorean theorem, and you actually know quite a bit of this, and so I feel like a lot of it you could do on your own, but there's just a couple problems that I want to run through. So let's go to page 2. So obviously Pythagorean theorem only works on a right triangle. A and B are the legs, C is the hypotenuse. So let's do a quick example. If we know we have an equilateral triangle and each side length is 12, we want to find the length of the altitude. So we know altitude makes a right angle, so that's likely our right triangle. So when you draw it out, I said, okay, all side lengths are 12, and I also know that an altitude in a equilateral triangle is also the median, and so it splits this into two congruent sides, and so that's why I said that this is 6. So I did Pythagorean theorem, so here's A, or this can be A, it honestly doesn't matter. The legs do not matter, it just matters that they're equal to the hypotenuse. So I did, A squared plus 36 equals 44. I subtracted, and then I simplified. So if it is a radical, you want to keep it in simplified form. Okay? All right, let's take a look at the next one. Feel free to pause at any point to try it out first and then check your answer, because I am going to go through this pretty quickly. So this one says the perimeter of a rhombus is 68. Well, here's what I know about a rhombus. All the sides are equal. So I took the 68 and I divided by 4. I also know that the diagonals in a rhombus are perpendicular bisectors of each other. So when I drew my picture, it looked like this. So I know that there's a right angle in the middle here. If the diagonal is 30, then I know this is 15. So again, I've got my hypotenuse and I've got a leg. So I did Pythagorean theorem, simplified, and I got A is plus or minus 8. Now I threw out the negative because obviously we're not going to have a negative side length of 8. And then, so this is 8, but the whole distance is going to be 16. So keep that in mind that they asked for the full distance, not just the side. So I needed to times it by 2. Okay. All right. The next one is a really good one to draw a picture for. So if you take a look here, cover that up. So it says Miss Suffren ran 2 blocks north. So let's draw that. So 2 blocks north looks like this. Then 5 blocks west looks like this. So that's going to be a right angle there. Then 4 blocks north, so there's 4. And then 3 blocks west, so there's my 3. And then I want to know if she decides to go straight, how far would she run? Now here's the thing, since this is 2 and this is 4, and 5, these are not equal, and so these don't necessarily, I can't just find hypotenuse, and then add them together. So what I'm going to do is, if I extend these lines, they will meet at perpendicular, or at a right angle and be perpendicular, and this will be a rectangle. So if this is 4, this will be 4. If this is 5, this will be 5. So I have created a large right angle. So this side is 8 and this side is 6, and then I can run through Pythagorean theorem because I am trying to find the hypotenuse of the whole distance. So I got 100, which means that this is going to be 10 units. Now, this is what's called the Pythagorean triple, which is in section 9.6, which I think we're going to skip, but it's good to talk about. So Pythagorean triple is just 3 numbers that fit Pythagorean theorem, and they're not decimals, they are whole numbers, they all end up as perfect squares. So 3, 4, 5, for example, 3 squared plus 4 squared equals 5 squared. And then a variation of that is if you times them all by 2, you get 6, 8, 10. And so that's what we had here, 6, 8, 10. If you times them all by 3, you would get 9, 12, 15, and that would be a Pythagorean triple. So just something to keep in mind. We'll talk about it a little bit more, but these are numbers that just all work out very nicely. Okay, so let's take a look at the next slide. So next one is a converse of the Pythagorean theorem, and it basically says if the square measure of one side of a triangle equals the sum of the other two sides, then the angle opposite the longest is a right angle. So, I mean, that's Pythagorean theorem. So a squared plus b squared equals c squared. The thing is that you have some other things that go along with it where you can actually classify triangles based on the side lengths and how they work in Pythagorean theorem. So if you take a triangle or side lengths, for example, and you take the two smaller side lengths and the longest side length and you square these, add them together, and they equal this, then it's going to be a right triangle. If you square them and they're bigger than the biggest side, then it'll end up as an acute triangle. And if you square them, add them, and it's smaller than the longest side, then it's going to be an obtuse triangle. Okay, so let's try that. Okay, so this asks what kind of triangle is formed. And so this is what they're asking, if it is obtuse, acute, or a right triangle. So obviously 4 and 5 are my smallest sides, so when I plug them in, I'm going to square them and add them together, and then 6 will possibly be my hypotenuse. So let's just simplify. I get 16 plus 25, which of course is bigger than 36, making this triangle acute. And that's it. You just have to classify. Okay. Over here, 5 and 3 are my smaller sides. 12 is obviously the biggest side. So if I square and add, I end up with 34, which is of course less than 144, making this triangle obtuse. Okay, so I would give those a try, maybe pause the video and try them out, and then I will show you the answers. So if you want to give them a try before I move this paper, pause. Okay, so here's what I got. I got these both as obtuse. Obviously, if they're equal, it's going to be a right triangle. Okay. Okay. Okay, so for the next ones here, it just says find the missing length in terms of the variables, and so you're really just you're substituting into Pythagorean theorem, and you're just simplifying as much as possible. So obviously these are my legs. So I did 2a squared 3b squared equals ab, because I'm trying to find the hypotenuse, and then I squared everything. These can't be combined, so I mean 2 squared is 4, 3 squared is 9, and then I just squared the variables, and then I mean just square root it. There's really, I mean, there's not much to it. I'm just basically testing, do you know what can and can't be put together and simplified. Okay, so in this one, so this is actually my hypotenuse, and then BC and AC are the legs. So I said, like here's my hypotenuse squared equals 2y squared AC squared. So in this one, okay, you multiply exponents, so I have x to the 4th, 4 and then y squared, and then I would need to subtract the 4y squared, so x to the 4th minus 4y squared, and then square